All right. So when you're working with one like this, you got to work backwards from order of operations. Now, when you do one like this, you have to remember that you cannot distribute the 1/4 into the 4 because the 4 is captured by parentheses being raised to the 2x. So you can't touch that at all. So you have to work everything else around it. So subtract the 4 or subtract the 1, you get 1/4 4 to the 2x is going to be 4. How do you undo multiplying by a 4th? You multiply by its reciprocal. Or do that, and you get 4 to the 2x, excuse me, is 16. At this point, you can do one of two things. You can just take log base 4 on both sides, or rewrite 16 as a base 4. Either way, it's pretty easy. I'm going to rewrite it as log base 4. And what happens to my log base, my two bases? And you get 2x equals 2. X is 1. Did I say log base? I meant exponential base. Sorry. All right, and that's how that one would work out there. Yes, ma'am. Which one? What is it? Do you have a question on this one? All right, I'm gonna do 42 real quick. Jordan, you all right on that? It's like one too many. I'm joking with you. You know that, right? No, seriously, I am. I'm just being a sarcastic jerk because that's what I do some days. Shut up. Turn on to me. You want to go? Let's go. Just gonna stand up, throw her desk in the air. I'll shank you. All right, same idea. Same idea. First thing we do is we got to move that negative 16, so we add it over. 0.2, 10 to the x is, what is that? 51. Divide by 0.2. I don't know what you're going to get. 255. Thank you. And now in this case, I can't rewrite 255 as a base 10. So I have to take the log of both sides. Here my log base is just the common log, so I can use the alpha window 5 if I want, or I just hit the button that says log, and I get x will equal the log of 255. Whatever that winds up equaling, some decimal thingy of things. Okay. Let me get Colbert real quick. Sir. Yeah. Okay. Oh, really? All right, let's take a look at it. First thing you're supposed to do here is divide by 6.5. So if I divide by 6.5, let's see, I need a calculator. So it's 20 divided by 6.5 and hit enter. Okay. I'm gonna leave it as my decimal because the calculator will do it. So now I have this equals the log base 5 of 3x. So I have to 5 this. Okay? So I hit 5 to the answer. Gives me that. Now that should equal 3x. Did you hit a button wrong? It's super easy to hit a wrong button. It's really, really easy. Remember, you don't have to keep it in fraction form as you go through these things. Let the calculator do the work, and just, if you have to just kind of write down a quick decimal so you know what operation you're doing next, go for it. But you shouldn't have to worry about that one in there. Okay? Yes, ma'am. Did you round something off in a different spot? Don't do that. Try to remember. Yeah, don't do that anymore. Whatever you're doing, I was like, repeat sorry, it's a joke. I'm sorry. I'm sorry, Jared. Air fine. Oh, So what I'm saying, getting at here is the more you use the button that says answer, the more accurate everything is going to be. Don't truncate up front. I mean, I had kids that we were doing like Pythagorean theorem stuff in geometry, and they were rounding the nearest whole number when they were trying to solve side stuff, and they were off by like lots. Like, don't do that. Jordan, what can I do to help? Okay. Just try to stay away from it. I mean, and in all honesty, what did you say your decimal was, Nina? It's so close-ish, and if you had some work written in there, I knew that you probably rounded something at some point in time. Try not to. Yeah, and it's the same thing. It's just try not to. It becomes more of a cleaner answer at the end as opposed to truncating it up front. Because the sooner you truncate something, the further away it's going to get from the real answer as you go through the whole thing. What else we got, guys? Yes, ma'am. 41. So log base 2 of x is, that won't work. That one? So in this case here, I have nothing to move on the left-hand side, so I have to it. I'd exponentiate it with a 2. By exponentiating it, 2 to the log base 2 of x becomes x, and 2 to the negative 1 is 1/2. What a great singer. No, I find better. Because I can and I can bounce on one foot. Watch this. Whoa, it's tough. I can do this too. And that's what it's all about. No, too many things. No, too many things. You won't get this humor next year. I'm telling you guys, we're like go to class and you go, Murphy used to do stupid stuff. Stuff and things and stuff, whatever. So, excuse me. When we go back to, I guess we go back and start thinking about what we've done in chapter 8 is, all right, historically, this chapter tends to be probably one of the easiest things we do throughout the entire semester. And you may or may not have started to feel like, that looked weird, but the procedural stuff to it was, oh yeah, it's kind of the same thing over and over again, right? Am I okay in assuming that general sense? I mean, normally after a while, after teaching for a while, you kind of learn how to, you know the term feel of the room? If you're in forensics, you probably know how to play to certain things and stuff like that. You get a general sense, a general feel for how people body language, and like, or you're going through it, yeah. So you start to get going through it. So when we started go back to where we were at to begin with, we did exponential growth. Excuse me. We did growth and we did decay. Now the difference between the two was very, very subtle. Well, remember, the only difference between growth and decay was B was greater than 1, or B was less than 1 but greater than 0. That was the only difference. Exponential growth and decay, those guys had horizontal asymptotes, whereas when we did logs, they had vertical asymptotes. Hey, what do you want? You want all of them? You're out of here. Oh. Are you leaving, Lena? She's not leaving. All right, well, never mind. I was going to give you things, but now I don't have to give you things. So the difference between the two were growth and decay. When we did these things via graphs, what we always looked at was we made a quick table. We did -2, -1, 0, 1, ones and twos, and we had very easy. We made and calculated very easy points. All of those parent, bless you, all those parent functions were, the -2, -1, 0, 1, and 2, and then whatever it generated a y value. Then the shifted function was x plus h, and then y plus k. And then obviously, if it was -3 for an h, you'd subtract it. So it was like plus or minus depending upon the problem. And you just shifted it and went along your own merry way. That was pretty quick and painless. There wasn't too much parts to it where you guys were like, oh. Even when we did exponential E, the only thing that stunk about that is that you couldn't really get away with using E to graph anything by hand because it was always decimals. So we kind of shied away from graphing E's too much. We did a couple of them, but it wasn't anything too crazy. After we did this, we talked about what was called the growth models or the decay models. And growth and decay models also looked very similar to this, but the difference was this value of B was thrown inside of parentheses. And that's how it was generated to become either larger than 1 or less than 1. So if you had a growth model, it looked like it was y equals some value, 1 plus a rate to some time. What's that? I won't tell you which is which. I won't give you the like exponential growth decay like in terms of graphing one, but all of the modeling ones where you have PERT and continuous compound one, the continuous one that's PERT, but the other one where it's the N over R. Yeah, with whatever times they compound annually or something like that. I'll give you the formulas. I won't tell you which is which, but you'll be able to figure it out. This part was called the growth factor. And then the other one was y equals a, and it was 1 minus the rate. Remember, rate was the percentage written as a decimal over some amount of time. And this part was the decay. So if your growth factor happened to be 1.63, that means your percent increase was 63%. Okay, not 0.63, percentage-wise, would be 63%. Because if it was 0.63%, then it would be 0.0063. A lot of numbers. And that's what we did with those. And remember, when we dealt with those, a lot of times they were giving you formulas right off the bat, and you just kind of had to look at the table and find out, after so many years, you would know when things would change over. Right? After that, it got to be something a little bit more interesting. Oh, I think the only other part here is we did a bunch of decay problems that had like depreciation. You buy a car for $20,000, it depreciates at 12%. What's it worth after 7 years? That kind of thing. Right? Then you had your money ones. Your overall amount is equal to your principal. Yeah, your initial amount, 1 plus the rate over the number of times compounded to the number of times over years. And then you had, those were the two amounts you had. Remember that that expected amount, is how much you have at the end. P is your initial amount, your principal, how much you put in. We made a joke about this this morning, where we said if you wanted to have $1 million. So, for example, if you wanted to have $1 million after you start work, let's say you guys get out of college and stuff like that, and you go into the workforce around age 25-ish, and let's say you have to work for 40 years, which means you'd be how old? 65, yeah. It is. Welcome to my world. How much money would you have to invest at age 25, retire at 65 to earn $1 million? Let's say you've got a banker friend. He's a guy that walks around all the time in suspenders, and he's got one of those collared ones with like the old fashioned like stitch on ones. When you open it up, it just kind of goes. I don't know, because he wears a cool hat. He wears one of those cool visor hats. So it's green, so you can kind of see through. It's sound like a shade of the sun, but it looks kind of shady, like he's dealing cards. So you got this image of this dude in your head who's your banker friend. He's not laundering money for the cartels. No, not at all. But he said, hey, I'll give you a good rate. He says he'll give you a rate of 4%. I'll give you 4% over the next 40 years. How much money do you have to give me to earn that $1 million? So what you had to figure out was, okay, Mr. Banker friend. 4% is what is a decimal? 4. Then you have to ask your banker friend, hey, Mr. Banker friend, all of a sudden turned into, hey, boo-boo, let's go get a pig in a basket. What's that guy's name? Yogi. Yes, I forgot. Like, hey, boo-boo. So you act like Yogi Bear, and hey, Mr. Ranger friend. How many times? Sorry. Let's say he's going to be nice. He's going to compound it, monthly. All right, he'll compound it monthly for you because that's what he does. This is kind of. And if you're looking at you're compounding it monthly, last time I checked, there's 12 months, right? So we have 12 times 40 years. Now, in order to figure out how to solve for P, you basically are just working backwards. You got to figure out what all of this equals, and then take 1 million. Every time you say million, I do this. $1 million and divide it by that, right? So you're going to be really sad here in a second. So sad. Is that what someone just said? So you have to take 1 million. You know, being a fresh out of college, I have no problem coming up with $202,000 and $202,434.43. Chump change. Let me write you a check. Ooh. That's a 9, right? That's a 9, yeah. Okay. Because that's the same as.
I know, that's what I was doing.
So it'd be 2.
Yeah.
You said 3.
No.
You had 3 fingers up.
I had 2.
I swear you had 3.
2.
I swear you had 3. I swear you can't see it. Okay, I apologize. I swear I thought you had 2 fingers up.
3.
That's why I was like, because there's 2. She's like this. I'm like. So yeah, that's depressing. Yes. Yeah. So you gotta give to the bank. I'm glad you paid you Tuesday for a hamburger today. Yes. Yeah. For depreciation, is depreciation be a growth or a decay? What's that? No, no. No, what? When you use PERT, you use PERT when you see the word continuously. If it says it's compounding continuously, then you use PERT. If it doesn't say continuously, you're compounding interest. It'll say it's annual, semi-annual, quarterly, monthly, daily, hourly, secondly. Yes, ma'am. For this part, yes. Great question. The parts that I would say that you would not get a calculator for would be if I asked you to graph an exponential, or I asked you to graph a log piece, because you can do that without having to do that without a problem at all. Also, I might ask you to what is it, like log? What's log base 3 of 9? 2. I Sorry. I swear I thought you had 3 fingers. My eyesight's old. No solution. You can't do it because you can't take log base of a negative. Okay. What's the inverse? I'm sorry. Rewrite that as exponential. B to the x. Okay. So if you start thinking about it, if I want to know what I want to write that as log form, what would it look like? Log base 2 of 16 is 4. Good. Okay. That's about as complex as you can get without calculators, because then everything else was solve for x, or having to find those weird values on the calculator via tables and things like that. Oh, I was trying to get the picture, trying to go. Sure. Okay. So what I did was, I took some old problems from the past couple of years, put them together, a whole bunch of things. So what I did here, like I was saying, is that I took a bunch of old problems from the past few years. Do you know one? Good. Now, I would say you guys were asking about calculator, non-calculator stuff. You're a good sport. I would say that of these first 1, 2, 4, 5, 6, probably the first 14 would be the ones that you would be able to do without using a calculator. Expanding, condensing, things like that. Those are pretty straightforward. Yeah. Not. Yeah. Yeah. You need a calculator for that. Finding some ordered pairs. It's easy. Same thing with the log graphs, the 21 and 22. And everything else on there on this first couple of sheets there, those would all be regular on the calculator. Real quick, I want you to look at number 11 and number 14. Number 11 and number 14, the solutions that they give you are a little bit weirder than what I would have written. So if you, oh yeah, by the way, there's answers for the first 2 pages at least, 3 pages. I don't care. So if you look at the solutions on number 11, see how it says log base 3 of w plus log base 3 of u over 2 plus log base 3 of v over 2? That means the exact same thing as this. 1/2 times the log base 3 of u. All right? We wrote it out in class when we started out with that. We had log of w, that was the square root of u and then v. What we would have done was, oh, what base was this? Base 3, sorry. We know that this is going to be multiplied in here. So you knew that was going to be a w times a u to the half and a v to the half. And as we went through it, we would have just split it into 3 separate. Log base 3 of w times 1/2 log base 3 of u times 1/2 log base 3 of v. Oh, thank you. I'm sorry. Yeah, plus. Sorry about that. Now, the reason I skipped the step there by, I knew that since it had an exponent, I knew that exponent was going to go in front of a log eventually. So I just kind of threw it in there. We always left it like that. You don't have to put it over 2. Okay? You don't have to put it over 2. That just seems silly. Silly. Same thing with 14. Excuse me. Same thing as you go, if we look at number 14 real quick, we've got log base 2 of the quantity 12 times 5 to the 4th all squared. 14. Now, in my mind, what I'm seeing here is that I've got a 2 out in front of this square. It's going to jump out in front of the log. You be okay with that? So that 2 is going to go out in front of the log to start with. Then I have the log base 2 of 12 times 5 to the 4th. And now what I'm going to do is worry about the stuff that's within the parentheses. And again, it's going to look eerily similar to what the answer they give. But leaving it the way that we've been doing it is going to be absolutely fine. We have 2 at a log 2 of 12 plus a log 2 of 5/4. But what can I do with that for? What's that? Perfect. Absolutely. I would just put it here right away and then close my parentheses. Okay. If you look at the answer that they have on the back, they distributed the 2 into the parentheses. And they wrote 2 log base 2 of 12 plus 8 log base 2 of 5. Leave it like that. It'd be right. It'd be fine. I just never went that extra step. Because knowing what it looks like expanded like this, it seems kind of silly to do that. I wouldn't write it. Hi, Devin! Hi. Hey, good conversation. Don't trip and fall, otherwise you have to sit on the floor. Oh yeah, if you do it twice. If you do it 3 times, you have to sit on your head. Yeah, right. Now, skip ahead to a couple of the word problems that I put on here. What I did was I found some old word problems that actually came out of an econ book. Notice they're all kind of the same thing. One of the things I wanted to show you here, I'm on where it says, the second part where it says Martha makes an investment of 500. If you look at part C, it says, what is her effective annual rate? Don't worry about it. Same. Yeah, I'm never going to ask you anything about this annual rate stuff. That's a whole different other thing, and we're not worrying about it. Same thing where you see that on the next C value says, what's the effective annual rate? But I really do like the wording on number 5. A loan shark lends a gambler $1,000 to cover a debt. He charges 35% annual interest compounded continuously. How much does the gambler owe the lawn shark? He's that lawn shark. He's out there with his chair and his his watering can. It's land shark. 80 grand. How much does the gambler owe the loan shark at the end of a year or 2 years? A lot. Yeah. Anyway, so in that case, you have your initial amount. You just got to figure out the rest. That's a PERT problem. See how it says continuously? Then you know you're using PERT. What's that? Yes, because he's giving you $1,000 to start with. And I'm pretty sure he's going to charge more than 35%. Not that I know from experience, but I don't think a loan shark is going to allow you to hold that loan for a year. Pretty sure it's going to be like a week. I don't know for certain. Or are they real? I don't wear shorts very often, do I? So is it possible that I have fake knees? You'll walk up to me and kick me. Hey, that could be a good extra credit question. Does Murphy have fake knees? Loan shark. Booze. Yeah. Last name Shark, first name Loan. Esquire. I am the Loan Shark. Hey, did you know that there are three? I've done this with there are 3 twos in the English language. There's also 3 do's in the English language. You have? You said doo-doo. I'll hang my head and shake. Okay. What's that? First problem, how do you start it? No. In this one, I would look for my parent function. My parent function is just -4 x to or 1/2 to the x. Yes, ma'am. Huh? Yeah, it's the k. Because b is less than 1. Yeah, you know why? Look at what's the a value? So you remember decay goes down to the right, or it can go up and right. No, it depends upon it's the standard form because the a value can convert it. So when you go through this one, you're just picking out values, right? 1/2 to the -2 would be would it be 4? So it'd be 4. So what's 4 times -4? -16. 1/2 to the -1 would be 2. -4 times 2 would be -8. -4 times 1. -4 times 1/2. And -4 times 1/4. Those are your initial ordered pairs. To those, I would just have to shift them, the h and the k. The parent functions. Now remember, your h value in this case is -2, and your k value is +2. So to each of my ordered pairs, I'm going to take x -2 in this one, and I'll have y +2. What's up? It's +2. Sorry, I said +2. I don't think you saw that as well. What's up? No, I didn't have one. I can make one and you guys stop by in the morning and look at it if you want. I'll do that. Yes, lady. How do I get what? H? H, remember, it's always x minus h. So that means this has to be -2. So now all I have to do is take, well, what's -2 minus 2? Well, it's -4, -3, -2, -1, and 0. And then my other ordered pairs is just add 2. -14, -6, -2, 0, and 1. That's all you have to do for these graphs. I mean, it's literally, that's all it is. It's nothing. Oh, well, you have to. You'll be looking at it. Now, when we have the asymptotes on exponential growth or decay, remember the asymptotes are horizontal asymptotes. It's at k. They don't have verticals. The verticals are logs. Because remember, logs grow from trees, and trees go up and down. Asymptote. Graph what? No. No, graphing because you have to think of decimals. I'm not going to make you do that. I'm a jerk, but not, 3s and 2s, I don't know the difference. It's like, what is the square root power? Nina, what do you got? Yes, ma'am. Yeah. You're not. You press a button on your calculator. Yeah. Because trees come from logs, they go up and down. The horizontal asymptote is always at k. The vertical asymptote is at h. No. For exponential growth or decay, there's only a horizontal asymptote. Oh, I thought you meant as there would be 2 of them. I'm sorry. I misunderstood. Yes, you would be at 2. BNY equals 2. Thank you. I misunderstood. The whole number 2 thing. It's our thing. We got a thing. She's got a square root. You've got a 2 and a 3. I don't know what else. They'll sit here and just make fun of her brother all the time. It's great. Shivky, because he's a shivky. Yes. Yeah, where do you guys go? It's exponential, so it means it's going to be at k. Remember this. Log. Remember, the easiest thing to remember about this, logs come from trees. Trees grow vertically. So logs have vertical, where vertical lines are at, and vertical lines are always x equals a number, so it has to be x at h. Not k. Yes, ma'am. Parents die.
Do we have to show this graph like all the time?
Yeah, we can ask order pairs. I can only do a lot of pairs.
Okay.
Like, where's an asymptote? What's an order pair?
Okay.
Yes, sir.